So in the last session, right, so we started discussing about the Postgres database architecture, where we have seen, different types of architecture, like what is general purpose architecture and what is memory based architecture as well. So in the memory based architecture, we discussed about the shared memory areas and local memory areas. So what is shared memory area? So shared memory area is a memory area which is accessed by all the background processes in Postgres, whereas local memory area is a memory area which is assigned to per process. So this is a private to the process or it is a local to the process. So amount of memory that we are assigning to any of the components of the local memory area is per process, right? So and we discussed about what are the subcomponents that we have in shared memory areas like val buffers, shared buffers and clock buffers. And we have also discussed about, like what are the components of this memory area called local memory area. Like we have work memory, we have maintenance work memory, we have auto vacuum work memory, and we do have temporary buffers. So with that we have concluded the concepts of memory based architecture. The next topic that we are going to discuss is we are going to discuss about the process based architecture in Postgres. Okay, so most of the processes are already covered while we were discussing about the memory based architecture, but anyway we will be doing a rewind of them. Okay, so the process based architecture. Okay, process based architecture. So depending upon the types of processes, right, so this process based architecture is divided into two parts. Okay, depending upon the type of processes we have in Postgres, this process based architecture is divided into two processes. One is mandatory background process. 1 minute. One is mandatory background process, second one is optional background process. One is a mandatory background process and second one is what? Optional background process. What is mandatory background process and what is optional background process? So the name itself says, right, so mandatory background process are mandatory to run the Postgres cluster. So whenever the Postgres cluster is running, this process will should always run. Okay. What are the optional background process? Optional background process are options. Whenever you enable some option, let's say we were discussing about the archive log mode. So when you enable the archive log mode, archiver process will come into picture. So whenever you enable the logger, the logging collector will come into picture. So whenever you enable the auto vacuuming, auto vacuum launcher will come into picture, which means, so depending upon the options that we have enabled and disabled, this optional background process will come and disappear. Okay, they'll come and disappear. So options, so when you enable that option, the background process will come into picture. When you disable that option, the background process will disappear from the Postgres cluster. So but the whereas in case of mandatory background process, right, they are mandatory to run the Postgres cluster. If they are not running, we will not be able to run the Postgres cluster properly. So we will be discussing what are the mandatory background process that we have in Postgres, and also we are going to discuss about what are the optional background process that we have in Postgres. Okay, so what are the mandatory background process that we have? Mandatory background processes. What are the mandatory background process that we have in Postgres? We have BG writer, we have val writer, and we have checkpointer. So these are all the mandatory background process that we have in Postgres. What are the optional background process that we have? So we have stats collector, we have auto vacuum launcher, we have archiver and logging collector. So these are all the optional background process that we have. So we have mandatory background process and we have optional background processes. So now we are going to discuss about each process one by one. If you see, some of them are already covered, anyway we will be rewinding them. Okay, so the background writer. So what is the background writer? Background writer is a process which writes what? Dirty data from where to where? Shared buffer to the to disk when on the event of commit or checkpoint. Okay, so what is the background writer? Background writer is a process which is responsible for writing dirty data from shared buffer to the disk on the event of commit or checkpoint. So what is dirty data? If you remember, when we were discussing about the memory based architecture, we have stated that shared buffer is going to hold a dirty data. So what is dirty data? Dirty data is a data which is modified but not yet written to the disk. So who is responsible for writing this dirty data? Background writer is a process which is responsible for writing this dirty data from shared buffer to the disk on the event of commit or checkpointing. So what is the next background process we have? The next background process that we have is a val writer. So what is the purpose of val writer? Val writer is a process which is responsible for writing this val data. Okay, val writer is a process which is responsible for writing this val data from val buffer to the disk. Okay, val writer is a process which is responsible for writing this val data from val buffer to the disk on the event of commit or checkpointing. So if you remember what is val data, whenever you perform any transaction, so what is going to happen? The actual transaction is going to happen in shared buffer, whereas information about the transaction is going to get stored in what? Val buffer. What is the purpose of val data? So whatever the data that is stored in val buffer, we call it as a val data. And what is the purpose of this val data? This val data is used for the instance recovery. So val writer is a process which is responsible for writing this val data from val buffer to the disk on the event of commit or checkpointing. And where it is going to write on the disk, we have a directory called data directory. So what is data directory, that we will be getting to know in the Postgres installation class. Okay, so what is data directory, that we will know in the later classes. So in Postgres there is a concept called data directory. There is a concept called data directory. Under this data directory we will be having one directory called pg underscore val. So pg underscore val is a data dictionary, sorry, pg underscore val is a directory in which the val files will get stored. Okay, these val files will get stored. Who is the process, which process is responsible for doing that? Val writer is a process which is responsible for writing the val data from val buffer to the disk on the event of commit or checkpointing. So the next mandatory background process that we have in Postgres is checkpointer. The next background process that we have in Postgres is a checkpointer. So what is this checkpointer, right? So whenever checkpoint happens, okay, whenever checkpoint happens, what is going to happen? So then the checkpointer sends a signal. Okay, checkpointer sends a signal to the val writer, so that val writer will write data from val buffer to disk. Okay, so whenever checkpoint happens, okay, whenever checkpoint happens, what would happen? It sends a signal to the val writer, so that val writer writes data from val buffer to the disk. Once that is done, it is also going to send a signal to the background writer. It also sends a signal to the background writer, which and then background writer writes that corresponding dirty data. What does it mean by corresponding dirty data? Means whatever the val data that has been written to the disk. So with that val data, something has been modified in the shared buffer, right? So the corresponding dirty data from shared buffer, background writer writes this corresponding dirty data from shared buffer to the disk. So checkpoint signal sends a signals to the val writer, and then once it is done, it is going to send a signal to the background writer to write the corresponding dirty data from shared buffer to the disk. So this is about the checkpointer process in Postgres. The next background process that we have are the optional background process. What are the optional background process we have? We have a stats collector. So don't get confused with this stat collector with the analyze what we have discussed in the last class. What we have discussed, analyze is an operation to what, to gather the statistics on a table, so that what happens, analyze is an operation to gather the statistics, so that what happens, the optimizer is going to use a better execution plans to perform the query execution. That's analyze is different from the stats collector. So what the stats collector is doing, right? This stats collector is not going to help the optimizer. So what it will do, right? Stats collector is going to gather the stats. When I say stats, right, when I say stats, right, 1 minute. All right. 1 minute. Yeah. So when I say stats, it's not like so what happens, right? This stats is different from the analyze operation. So when I say stats, it is going to gather the statistics about how many number of times particular index has been used. How many times particular index is used, and okay, how many times particular index has been used, and how many times particular function has been called. Okay, and so it is also responsible for, okay, it is also responsible. So let's say as a DBA, you might encounter a question from the application team stating that could you please check and let me know what are all the sessions that are running in the database, right? You might get a question from that stating that what are all the like what are the queries that are running in the database. Then what happens, so how it is responsible, so stats collector is a process which is going to monitor this. So stats collector is a process which is going to monitor, okay, which is going to monitor the queries that are being running against the database. So stats collector is responsible for what, monitoring the queries that are running against the database. And so in Postgres, you will come to know in further classes, in Postgres there are some tables called pg underscore stat. It starts with pg underscore stat. So stats collector is a process which is responsible for populating data into the pg stat tables. Okay, stats collector is a process which is responsible for like providing the information to the pg underscore, populating information or data to the pg underscore stats table. So the next background process that we are going to discuss is a logging collector. The next background process that we are going to discuss is a logging collector. So what is this logging collector? So logging collector is by default it is disabled. It is disabled by default. How can we enable it? How can we enable it? Right? We can enable this logging collector by changing a parameter called logging underscore collector. Logging underscore collector. How we can do that? We will be seeing it in the post installation. We will be seeing them. Okay, how can we enable these parameters and all? So if you make logging underscore collector equal to on, okay, if you make logging underscore collector equal to on, then logging collector will be enabled. Okay, then logging collector will be enabled. So how can we do that? So what is the purpose of logging collector? So as a DBA, if you are working as a DBA, if something goes wrong, if your database is not running, what is the primary source of information from which you will get the errors? That we call it as a alert log file in Oracle. So where it is going to write each and everything, okay, where it is going to write each and everything that is happening against with the Oracle database. Likewise, in Postgres also we will be having a log alert log file. The name would be Postgres underscore some date dot log. So what if something is happening in the Postgres cluster, everything will be written in detail in the Postgres log file. So which process is responsible for doing that? Logging collector is a process which is responsible for writing this, dumping this data, dumping this information into the Postgres log file. So if this logging collector is disabled, by default it is going to write the information onto the standard output device, which is called desktop. Directly it will be written directly into the desktop. To redirect this output to a particular file, then we need to enable the logging collector. So the next background process that we are going to discuss is a auto vacuum launcher. So if you remember when we were discussing about the auto vacuum work memory, so we have discussed about a process called auto vacuum worker. So what is the purpose of this auto vacuum worker? Auto vacuum worker is a process which is responsible for performing the auto vacuum and auto analyze operation. So how many auto vacuum workers will be created? It depends on a parameter called auto vacuum underscore. It depends on a parameter called auto vacuum underscore max underscore workers, right? So it depends on a parameter called auto vacuum underscore max underscore workers. So what is the default value? The default value of this auto vacuum max workers is 3. So by default 3 auto vacuum workers will be created. Okay, by default 3 auto vacuum workers will be created to perform this auto vacuum and auto analyze operations. So then what is auto vacuum launcher? So auto vacuum launcher is a master process. Okay, auto vacuum launcher is a master process which is responsible for creating these auto vacuum workers based on a parameter auto vacuum underscore max underscore workers. So whenever a particular table reaches certain threshold, right? So what is threshold and when the auto vacuum will be run? Those things we will be discussing it in a separate class, but for now you need to remember whenever a particular table reaches a auto vacuum threshold or auto analyze threshold, auto vacuum launcher is a master process which is responsible for provisioning or creating the auto vacuum workers to perform auto vacuum and auto analyze operations. Apart from this, will it do something else? No. So this master process will spin up the auto vacuum workers to perform the auto vacuum and auto analyze operations. And how many auto vacuum workers will be provisioned or spinned up, that depends on a parameter called auto vacuum underscore max underscore workers. Okay, the next and the last background process that we are going to discuss about is archiver. Okay, the last background process that we are going to discuss is a archiver. So what is the purpose of this archiving? That we will be discussing in a while. So before that, let's talk about a scenario. So I have a master node. So what is this master and what is this slave, right? So let's say in any of the database, whether it can be Oracle or SQL Server, Postgres, MySQL or DB2, any database, so we are having a concept of disaster recovery and high availability. Okay, we are having a concept of disaster recovery and high availability. So what is this disaster recovery and high availability? So we are having a master. So I have installed Postgres database in one of the server. So how we are going to, okay, protect this master? When I say protecting this master, it's not about the protecting the, I mean, protecting the server. It's all about protecting your data, right? So if something goes wrong, let's say there is a ICICI database is there. If something goes wrong with the data center in which that ICICI bank servers are hosted, and everything we will be going to lose. So whoever using this ICICI bank, they will be in trouble. And so to avoid such situations, right, so the every database comes up with the concept of high availability and disaster recovery. So this high availability and disaster recovery talks about how you are going to recover your database, or how you are going to recover your data in case of any damage that happened to the data center on which your servers are located, right? So to discuss this, so there is a database which is running here in the another, okay, in some other location we will be creating a one more database which we call it as a slave. And this slave will be running in which mode? This slave will be running in a read-only mode, and whatever the data or whatever the changes that are happened in master, those changes will be automatically applied onto the slave to get the slave in sync with the master. So what does it mean by in sync with the master? Whatever the data that is there in the master, the same data will be there in the slave as well. So if something goes wrong with this, we will be having a data safely stored in slave side, right? So how it is going to happen, right? So whenever you do any change, okay, so actually where this change is going to happen, this change is going to happen in the shared buffer, and information about this change is going to get stored where? Information about this change is going to get stored in where? Val buffer.
One buffer.
Yeah, so whatever the change that is stored in the val buffer, so these val files will be copied over the network to the slave side, and this will be applied onto the slave, so that whatever the data modifications that are happened in the master, those modifications are also going to happen on the slave to get the slave in sync with the master. So which is playing a crucial role in this setup? Val files are going to play a crucial role in this master slave setup. So let's discuss about a scenario where, so there is a network disturbance between, okay, so if you want to copy the val files from master to the slave, there should be a network always available between master and slave, right? So let's discuss about a scenario where, so there is a network disturbance between master and slave, okay, for 1 hour. Okay, there is a network disturbance between master and slave for 1 hour. So there are two situations that will happen. One is either master has to keep all the val files which got created during this 1 hour of time, but it is possible no, because on the master these val files will be overwritten. So after 1 hour, when the network connectivity is established, okay, after 1 hour when the network connectivity is established, whatever the val file that slave is looking for, that might be overwritten on the master, okay, whatever the val file that slave is looking for, so that val file may or may not be available on the master. If the slave, if the val file that is required by the slave is not available, then will the slave will be in sync with the master? No. And you need to end up building entire slave server to get the slave in sync with the master. So here the val files are playing a crucial role, and if the val file is not available, we will be ending up losing data on the slave, and we will be ending up reconstructing the slave from the scratch. To avoid that, Postgres has introduced the concept of archiving. So, what is archiving, right? Archiving is a process of copying. Okay, what is archiving? Archiving is a process of copying val files. Okay, archiving is a process of copying val files from pg underscore val to archiving destination. What is this archiving destination and how can we enable this? That we will be discussing it in a separate class which is called archiving. Okay, so what is archiving? Archiving is a process of copying the val files from pg underscore val to archiving location. So by default archiving is disabled. By default what? Archiving is disabled. And how can we enable? To enable the archive log mode you have to change two parameter. One is archive underscore mode and second one is archive underscore command. One is archive underscore mode and second one is the archive underscore command. These two parameters are responsible for enabling the archive log mode in Postgres. Okay, so what is archiving? Archiving is a process of copying val files from pg underscore val to one of the archiving destination or location. Which process is responsible for doing that? Archiver is a process which is responsible for copying these val files from pg underscore val location to the one of the archiving destinations. So this is
Yeah, Rick,
about
then what about slave? Uh,
that we'll be discussing during the like the slave recovery. So in streaming replication, right, we are having a concept of slave recovery. So if the val file is whatever the val file that slave is looking for is not there in the pg underscore val location, right? So from where else it can get? It can get from the archive location. So on the slave side you need to set up couple of parameters such that so when the requested val file is not available on the pg underscore val location of the master, then slave will go to this archive location, it will pick up the file.
okay.
Okay, if that val
So
file is
if so, so it continuously it will take data from wall files only, right? Every time that slave.
yes, yes, yes,
If it is network or some problem, then it will after some time it will take from archive.
yes. So you do you know the concept of data card in Oracle?
Yes, yes.
Yeah. So what happens? So there is a real time apply is there, and one more thing is there, right? So when there is a real time apply, each log file online redo log will be copied to the standby. It will be applied. Likewise, if there is any issue with and if the online redo log file is overwritten, then from where it will take? It will take it from the archive files, right?
Yeah, yeah,
Likewise,
yeah.
it is also same in Postgres. Okay.
Okay.
So this is about
So
the
slave is like standby server. It is only
yeah,
for storing
same.
archive.
It is like a standby server.
Okay.
So
So we can see. So
what is your question?
no, no. Slave is like standby server or only for storing archives. Means if
No,
we
no.
if
Slave is nothing but a standby server.
so if primary crashes, we can
Huh.
um,
If
switches
primary
to
case, then we can
standby
make
also.
the standby as a primary. That's what we have discussed. Right? That's what I have told you, right? The
Yeah,
concept
yeah.
of high availability and disaster recovery.
Okay, okay.
1 minute. Yeah. 1 minute. Let me find out the best. You're able to see my screen, right?
Yes.
Yeah. See, so we were discussing about this Postgres architecture where so we discussed about the memory based architecture and we discussed about the process based architecture. If you see shared buffers, val buffers, clock buffers are there. So this is the memory components that we have and the associated background process like val writer, auto vacuum launcher, archiver, logging collector, stats collector, background writer and check pointer. So and val buffer, from the val buffer data will be written back to the val files, and from the shared buffer data will be written back to the data files, which means like disk. And from the archiver it will take the data from the val files and it will try to write the data into the archiving location. Okay, log files means the logging collector is responsible for dumping the cluster information into the Postgres alert log file. Okay, Postgres alert log file. So otherwise, if you want to see, this will be like, see, so there is a shared buffer and the other buffer areas are there. Shared buffer. So whenever client sends a request, let's discuss about the postmaster in other 5 minutes. Okay. Whenever client sends a request, postmaster is going to accept the request and it is going to create a special process called PostgreSQL Server process. This will be discussing it in another 5 minutes. Okay. And it will go and check whether the requested data is available in the shared buffer or not. So if the requested data is available, then we call it as a cache hit and the data will be written back to the client. If the requested data is not available, then it has to go to the disk, fetch the data, keep the data back in the shared buffer, and from the shared buffer it has to give the result back to the client. So whatever the data that the client is looking for, if the data is not available on the shared buffer, then we call it as a cache miss. So whenever you perform any transaction, so actual transaction is going to happen in a shared buffer, whereas the information about the transaction is going to stored in the val buffer, and val writer is a process which is responsible for writing this val data from val buffer to the disk on the event of commit or checkpointing. So what about the archiver? So archiver is a background process which is responsible for copying the val files from pg underscore val location to the one of the archiving destination. And logging collector. So what is this logging collector? You are able to see the diagram, right?
Yes.
Yeah, what is this purpose of logging collector? Logging collector is going to dump the cluster health information into the Postgres alert log file. The what is the location? The location of the Postgres alert log file is stored in the data directory. So what is data directory and all that we will be discussing it in a installation class. Okay.
Yeah, Hari, one doubt here.
Yeah, yeah.
So, um, our wall buffer is it will store dirty data also, right?
No, no, it's
Along with
not that data. So do you know something about the redo lag buffer cache in Oracle?
yeah, yeah.
So
So
what is
it will store update everything, right? Update insert.
metadata about the transaction? When there is a update operation that is happened in the so let's talk in the point of Oracle. Okay, so whenever you perform any transaction where actual data is going to get modified,
Yes.
database buffer cache, right?
Yeah.
So information about that update operation is going to stored in redo lag buffer cache.
Okay.
Ante so to simplify that, the actual data modification is going to happen in the shared buffer, and the what is the transaction that is happened, that information is going to stored in the val buffer.
Okay.
Okay, our metadata about the transaction, our metadata about the operation that we can call.
So
So
during recovery, we have only metadata, right? Then
yes,
if
metadata. So let's say there is a update emp set sal equal to 1000 that is happened, right? So during the
okay,
recovery, do you need the actual data? Or do you need the so what is the how we are going to perform the recovery? So we are going to perform the recovery by re-executing the operations, right? So if you want to re-execute these operations, you should know what are all the operations that are happened. How you would know the operations that are happened, where this information is going to get stored? This information is going to get stored in the val buffers or val data. So by using this val data, it is going to re-execute the same update operation so that it will be recovered.
okay,
Got it?
yeah, yeah.
So the next and last background process that we are going to discuss is a postmaster back process, which is very important. Okay. So the next and last background process that we are discussing about is a postmaster process. So what is the postmaster process, right? This process is also called as a Postgres process or supervisor process slash master process. So this is also called as what? A Postgres process or supervisor process or master process, right? So what is the purpose of this postmaster process? Okay. So whenever you start the Postgres cluster, so how to start the Postgres cluster, how to stop the Postgres cluster, and how can we find out the status of the Postgres cluster, that we will be discussing during the installation. Okay. So the point that you need to remember here is, whenever you start the Postgres cluster, the first background process that is going to get started is a postmaster process. The first background process that is going to get started is a postmaster process. This is also called as a supervisor process or a master process as well. So what are all the responsibilities of the postmaster process? This is one of the important interview question as well. Responsibilities of postmaster process. So what are all the responsibilities of the postmaster process? Okay. So this postmaster process is responsible for allocating the shared memory segments. Allocating shared memory segments. What does it mean by allocating the shared memory segments? What are the shared memory areas we have? We have shared buffers and val buffers depending upon the parameters. Okay, depending upon the parameters, postmaster is responsible for allocating these memory areas. Okay. So what are the associated parameters? Shared underscore buffers is one parameter and val underscore buffers is one parameter. So the moment Postgres cluster is started, the postmaster is responsible for allocating the shared memory segments. What is the next responsibility is? It is also responsible for starting up other background process. It is also responsible for starting up other background processes. It is also responsible for starting up other background process, which means what are the other background process that we have? We have a background writer, we have a val writer, checkpointer, archiver, stats collector, logging collector, and like logging collector and logging collector and archiver. So back this postmaster process is responsible for starting up other background process. And third responsibility of the postmaster process is, it is responsible for performing the instance recovery. Okay, it is responsible for performing instance recovery. Okay, it is responsible for performing the instance recovery. How we are going to perform the instance recovery, that we have already seen. And the next responsibility of the postmaster process, if any background process is killed, so you can correlate this postmaster process with SMON in Oracle. Okay, if any background process is died or killed, then postmaster will try to restart it. So if any background process died, then the postmaster will try to restart the background process. And the next and last responsibility of the postmaster process is postmaster acts as a listener. What it will do? Postmaster is acting as a listener. So what does that mean by postmaster acts as a listener? So whenever client sends a request, okay, whenever client sends a request, let's say this is a Postgres database that is running on 192.168.29.130. Whenever client sends a request, postmaster is going to postmaster is going to accept the request, and it is going to perform a special type of authentication called 1 minute. It is going to perform a special type of authentication called HBA, which we call it as a host based authentication. Okay. So postmaster acts as a listener. Whenever client sends a request, postmaster is going to, accept the request, and it is going to perform a special type of authentication called host-based authentication. So what is this host-based authentication, and what is the purpose of this host-based authentication? We will be having a separate class once the installation is done. So whatever the points that we were discussing, whether it can be a parameter file management or host based authentication or archiving or auto vacuum launching, so each and every topic will be discussed in a separate class in detailed manner. Okay, so postmaster is going to accept the request, and it is going to perform a special type of authentication called host based authentication. So how it is going to perform this host based authentication is using a configuration file called pg underscore hba.conf. What is the location of this pg underscore hba.conf? The location of this pg underscore hba.conf is a data directory, right? So in the data directory, we will be having a file called pg underscore hba.conf. Using that file, it is going to perform a special type of authentication called host based authentication. If the authentication is successful, then it is going to create a if the authentication is successful, then it is going to create a separate process called PostgreSQL server process, and handovers the request. Okay, and request will be hand over to the PostgreSQL server process. If the authentication is failed, then user is going to get a connection rejection message. Connection will be rejected. So what is host based authentication, that we'll be discussing in another class. And the pg underscore hba.conf is a configuration file which contains the list of trusted IP addresses. Okay, which contains the list of trusted IP addresses and the users from which the Postgres cluster has to accept the connection. So if let's say you are going to write, or you are trying to connect from to a Postgres, you are trying to connect to a Postgres database from a server 192.168.29. Some IP address, and if that IP address is whitelisted in the pg underscore hba.conf, then only your connection will be accepted. If the IP address is not whitelisted in pg underscore hba.conf, then your connection will be rejected. So what happens if your connection is accepted? If your connection is accepted, then postmaster is going to create a Postgres SQL server process and hand over that request to your Postgres SQL server process. If the authentication is failed, then the user is going to get a connection rejection message. So these are all the responsibilities of the postmaster process. So this is one of the important interview questions. So they'll ask you about what is the postmaster process and what are the key responsibilities of the postmaster process. Okay, the postmaster process is also called as a supervisor process, and this is the first process that is going to get started whenever you start the Postgres cluster. The postmaster process is responsible for starting up all other background processes and postmaster is responsible for allocating the shared memory segments. Postmaster is also responsible for restarting the background process if they die, and postmaster process is responsible for performing the instance recovery, and postmaster also acts as a listener. So whenever client sends a request, Postgres process is responsible for accepting that incoming connection, and it is going to perform a special type of authentication called host based authentication. So if the authentication is successful, then it is going to create a PostgreSQL server process and hand over that request to the PostgreSQL server process. If the authentication is failed, then the user is going to get a connection rejection message. So this is about the postmaster process. With this, we have concluded the PostgreSQL architecture. What are the questions that you would expect, right? The first question that you can expect from the discussion that we have gone through so far is, tell me about the Postgres architecture. If someone asks you about PostgreSQL architecture, no need to explain about the general purpose architecture. You need to focus on memory based architecture and process based architecture only. Okay. So when if you are able to answer this question, you will be able to answer anything in the architecture part, because sometimes instead of asking about the Postgres architecture, they might ask you about what is shared buffer, what is val buffer, what is auto vacuum work memory, what is maintenance work memory, and those questions they might ask you. And the next question that they can ask is, what are the responsibilities of the postmaster process? Okay, so with this, so we are winding up the session for today, and we'll connect tomorrow. Tomorrow we are going to see, we are going to set up the environment to, like, install our Postgres database or Postgres cluster. Tomorrow the class will be around like 20 to 30 minutes only, because I will be showing you how can we install the Linux machine in your Windows using VMware. So the actual installation is going to take 2 to 3 hours, but no need to see everything. Just I'll explain you all the steps that are required to install the Linux machine. Once that is done, day after tomorrow we are going to install the Postgres cluster. Okay, so that's it for today. We'll connect tomorrow again. Any doubts so far?
No.
Okay, then we'll wind up the session for today. Okay, thank you.